So Josh, let's move in from the prep conversation into the polishing conversation. And we'll go back to, you referred earlier to that a resin diamond is a polishing diamond. Talk a little bit about the polishing process. When would you consider that to start? I understand it can go all the way up to a 3000. At some point in there, I think you need to densify the floor to kind of give it that added strength that we've taken away in the grinding process. And also, let's talk about a true mechanically polished floor versus maybe some of the shortcuts or the abbreviated versions of a step-by-step process that may give you the same result as following a mechanically processed floor, but won't give you the longevity. So talk a little bit about the resins first and the diamonds and what are they designed to do? Are they still cutting at some point, or what exactly are they doing?
A resin diamond is always cutting. It doesn't matter what grit it is, whether it's a transitional 50 grit or if it's a pure resin 3500 grit, they're always going to be cutting. Very similar to sanding wood or polishing wood or sanding metal or polishing metal. The grits all matter. It's a matter of the fineness of the scratch that's being provided. The finer the scratch, the more refined the surface is. And then, of course, the finer it is, the more clearly it's going to reflect light or colors. That's basically the best way. That's the best way to explain if a resin's always cutting, because it's always making dust. There are no, at least in the systems that I'm familiar with, there are no redundant steps. There are steps that are there because we're trying to take a floor from, let's say, a transitional step at 100 grit, and we're trying to get to a 3500 grit. Unfortunately, we can't go from a 100 to a 3500 grit because the fineness of the scratch at a 3500 is so much farther from 100. We have to go through the individual steps to remove the aggressive scratches and make them progressively finer until we get full refinement.
So again, in that process, if you're still scratching with refined scratches, I assume you're kind of sealing the floor at the same time. When is the most ideal time to densify? Because at some point, I know there's the point of no return where you densify, but there's no more pores left in the concrete for the densifier to absorb. So based on your experience, when would you densify a floor within the polishing process?
As we talked with the diamonds and softness of the concrete or hardness of the concrete, when it comes to polishing, the biggest mistake that I see being made in the industry is sticking to a certain program of when a densifier should be applied. The reason I say that is because a densifier is made to make a floor more dense or abrasion resistant, which basically means it's helping the individual sand crystals to more uniformly and completely be fused together. The more difficult it is to break those bonds or those particles together, the better the polish is going to be because the matrix of the concrete itself is more adequately fused together. When is the right time? Again, it's going to come down to training and when the appropriate time is based on the hardness of the slab. So as an example, if I'm going to polish a floor and I'm grinding with a 70 grit and I'm getting a lot of much more dust, let's say, than I should be at a 70 grit, and of course that's subjective. But if the floor is coming out soft at a 70, I would be densifying at that point before I proceed with the 70. Because if the floor is that soft and it's making dust, that means the sand particles that I'm intending to polish and process are being pulled from the surface of the concrete. The densifier, which it's difficult for people to believe how it works, but it really does. The densifier grows a crystalline structure between the sand particles to make it more difficult to pull the sand from the surface. So the densifier makes the floor polish better because it more tightly attaches those particles that would otherwise pull free if it was soft. If, however, I'm on a floor that's, let's say, placed better than the previous mentioned, or it's a new slab, or for whatever reason, it's just a more dense surface, I may not have to densify until after my first transitional. So 2 steps later, perhaps. Again, there's no standard rule. The only real rule that I have for densification is there has to be at least one application of densifier. And if I have my choice of only one point at which I'd use it, it would be after my first transitional. That would be the only time that I would say, the point in the process where I would not vary. I would make sure I was at least past my transitional before I made it more dense. If the floor is soft, though, and again, this is where the experience is going to be so important, then there's a good chance by the time I get to my transitional, if the floor is soft, I'm going to have a result that is going to suffer later on because the densifier was applied too late.
Okay. Let's talk a little bit now about a chemical polish, which I think some of the big boxes in an effort to save money are skipping steps in a mechanical process, going to a chemical polish process, adding some chemicals, hitting a burnisher with it, getting a good initial shine, only to have that shine wear off prematurely because it's not a true mechanically polished floor. Talk a little bit about the pros and cons of that process and what it provides and what it doesn't provide long term.
Chemical polish basically describes exactly what it is. It's a chemical that's applied to the top of the concrete, whatever amount of refinement there is per the specification for the floor, that's what it is. It's then covered over with a wax and acrylic, let's just say a chemical that's meant to be applied in liquid form. And then once it's hardened, you run the burnisher over it and that gives it a shine. That is a topical product. That is the product that people will be trafficking, whether it's wheel traffic, foot traffic, it doesn't matter. That's the topmost layer of the slab. So that's the one that's going to see the abuse of traffic. Whatever the resiliency or the abrasion resistance of that chemical is going to determine how long a given amount of traffic is going to allow it to look the way it did when it was finished, which means eventually it will wear away. If a diamond pad on a burnisher can change its appearance, then it stands to reason that abrasiveness from the parking lot, sand that comes in on shopping cart wheels, eventually is going to erode or abrade away that topical material. It can be rejuvenated, it can be buffed, it can be cleaned, but any loss of that topmost material means that there must be a replacement of the material if it's expected to look that way again, meaning I would have to reapply it. There's really nothing wrong with that system because it does provide a good looking floor and it's going to provide some durability. Where the problem comes in is if the owner's expectations of that floor is of a mechanically polished floor, which has no topical material, and I'm walking on top of a mechanically refined surface, that yes, it can wear away from lack of maintenance, but there's no coating. If I own a floor that's been chemically polished or chemically treated, the owner has to be made aware that at some point in time, no matter how well they care for that floor, if they want it to look the way it did when it was finished, new coating or new material is going to have to be applied and burnished. It's not a problem as long as it's expected that that will be the case. Mechanically polished concrete, if I maintain it correctly and keep the abrasive grit that comes in on those shopping cart wheels and people's shoes, if I keep that surface clean regularly enough, there's nothing to peel away. There's nothing to wear away, unlike a chemical coating that's on top.
And it sounds like from an economic standpoint, you're investing a lot more maintenance and time into the chemically polished floor to have it maintain a look that you would gain the first time from a mechanically polished floor. Not that doesn't have some sort of maintenance involved in it, but I would think that the level of expense associated in maintaining that type of floor versus a chemical would be a fraction of the cost. So even though that mechanically polished floor initially may cost more to achieve, the savings would be there over years by having to maintain a chemically polished floor. Is that safe to say?
Yeah, I think it's definitely the decision to have one or the other is going to be driven by price. Without a doubt, a chemically polished floor is going to be cheaper than a mechanically polished floor because mechanically polished might need 5, 6, 7 steps to reach a certain amount of shine through refinement. And those steps cost money because that takes labor to do. If I use, let's say, a 3-step system with a chemical polish on top, well, I have less labor because I have less trips over the floor, and my chemical cost might be 10 cents a foot. So the chemical cost is low, there's less labor, but I'm meeting a price expectation of that particular client. As long as they're prepared for the ongoing maintenance costs, because a lot of businesses probably run on, a quarterly budget for floor maintenance. As long as it doesn't exceed that, then they've already budgeted for the maintenance that's going to be required there. So without a doubt, the mechanically polished floor is going to be less expensive over its lifetime to own, but maybe the client doesn't require that. Maybe they require or can't afford to, let's say, invest in that floor in the front. So they have to then own a floor that costs less to install, but more to own long-term.
Thank you for watching, and we hope you enjoyed this B&D series discussion on diamonds. If you find these tutorials informative and beneficial to your business, why not help support future videos and subscribe to our YouTube channel? And again, don't forget to click on that bell icon to be notified when we post future videos.